Pluto may hide an ocean of 100 kilometers in depth as salty as the Dead Sea. Pluto continues to surprise as researchers have found that the dwarf planet may hide an ocean of around 100 kilometers in depth and as salty as the Dead Sea. Surely we must find alien life somewhere within our solar system. Right? Ever since researchers got their hands on the data obtained as the New Horizons spacecraft overflew Pluto last year, they have been speculating on whether or not the dwarf planet could host liquid water beneath its surface. Now, geologists from Brown University have made an estimate of how the sea beneath Pluto may look like. According to their first conclusions, there is a high probability that Pluto harbors a massive ocean of around 100 kilometers in depth with content similar to that of the Dead Sea on Earth. Thermal models of Pluto's interior and tectonic evidence found on the surface suggest that an ocean may exist, but it's not easy to infer its size or anything else about it, said Johnson in a statement. We've been able to put some constraints on its thickness and get some clues about composition. While analyzing Pluto, researchers focused on Sputnik Planum. This region is believed to be a former meteor crater, produced when an object of around 200 kilometers, 125 miles, in width collided with Pluto. Basically, scientists looked at the position of the dwarf planet in relation to its largest moon, Charon. They found out that Pluto and Charon are tidally locked, meaning that the same side faces one another as they both rotate. The Sputnik plane lies directly on the shaft of the tides connecting the two alien worlds. It turns out that the Sputnik Planum is located directly under Charon, a telltale sign that there's a gravitational anomaly in the region. This suggests that the basin where Pluto's famous heart is located has what is called a positive mass anomaly, meaning it has more mass than the average of Pluto's icy crust. As Charon's gravity pulls on Pluto, it would proportionately pull more in areas of greater mass, which would eventually tip the planet until the Sputnik Planum was aligned with the axis of the tides. An impact crater is basically a hole in the ground, said Johnson, an assistant professor in Brown's Department of Earth, Environmental and Planetary Sciences. You're taking a bunch of material and blasting it out, so you expect it to have negative mass anomaly, but that's not what we see with Sputnik Planum. That got people thinking about how you could get this positive mass anomaly. According to researchers, after the basin formed, it was partially filled in by nitrogen ice. That ice layer supplements mass to the basin, but it isn't dense enough on its own to make Sputnik Planum have positive mass, explains Johnson, adding that the rest of that mass may be generated by a liquid lurking beneath the surface. What this tells us is that if Sputnik Planum is indeed a positive mass anomaly and it appears as though it is, this ocean layer of at least 100 kilometers has to be there, Johnson said. It's pretty amazing to me that you have this body so far out in the solar system that still may have liquid water.